Hey guys, I'm glad to see you all here. So my name is Samuel, and today I will be talking about a design pattern called property delegation. This is a great design pattern when it comes to using it with Kotlin. For sure, because Kotlin has dedicated support for this pattern. I will focus on explaining how to apply it in your Kotlin code. And also I will say about useful techniques when it comes to Android. So I'm going to start with the basics, just to make sure that we are all on the same page. So I will go step by step by describing the concept of the property in Kotlin. Then I will switch to the concept of the delegated property, and I will explain the motivations for using it in your code. And I will show how to implement your own custom property delegate. Next, I will say something about property delegates available in the standard library. And finally, I will say about applying property delegation on Android and about some trade-offs and disadvantages of using the built-in Kotlin support for property delegations on Android. So let's start with taking a look at the concept of the property. So as you can see on the right, we have a Kotlin property called name, and it looks pretty much similar to the declaration of Java field. But in fact, those are two different things. So what's the actual difference apart from the name? The thing is that the property in Kotlin, in fact, when it's compiled to the JVM bytecode, consists of the class field together with accessor functions, with the getter and setter. Also, in case of the immutable property in Kotlin, only the getter is generated, which returns by default the value of the corresponding class field. Thanks to the fact that Kotlin compiler generates the getter and setter functions, we are able to override them. And this makes the property delegation available in Kotlin. But as you can see, we can also use it to optimize our code, for example, by avoiding generation of the backing field in JVM bytecode. If we override the property getter to return the, for example, simple string, no backing field will be generated. Or if we want to access the value of the backing field, as you can see, we can use just field keyword in our getter or setter. Often we are using, apart from just simply returning the value of a backing field inside the getter or updating it in the setter, we are using some pre-processing operations. For example, like here, first we are trimming the value of our field, then we are capitalizing it. Also in the setter, we may like to check if the value passed to the setter is not null or if it's not empty, and so on. And here is the moment when we can start to ask some questions. For example, is this code clean? Or maybe let's imagine that we have a multiple class properties. For example, we have class user and the property name, or name with surname, middle name, or for example street. And we would like to apply all we'd like to apply the same set of operations while invoking getter and setter functions to all of those properties. So this is our use case when the property delegation can help us to extract the code from getter and setter function. So as you can see here, we've got the user class with two properties, and we are overriding their getter functions with the same set of operations. So in order to extract this implementation of getter functions, we can declare a separate class which will take over the control of our getters and setters. So let's take a look what this class should contain. It should contain two functions called getValue and setValue with the proper set of arguments, and yeah, this is it when it comes to satisfying the compiler, so that it knows that this class can be delegated to, that we can delegate our properties to an external object, and this is how the delegated properties will look like. So as you can see, we can make our entity class cleaner, and we can avoid duplicating our code. And this is really cool when it comes to reusing our implementation, but also it allows us to encapsulate our code and allows to extract the control of the whole property to some external object, which is cool, and it just fulfills the single responsibility programming rule. Also, inside the standard library, we have those two interfaces, read-only property and read-write property, which can help us in implementing those delegated properties. But in fact, you don't really have to use them, because, as I mentioned, compiler only requires the proper set of functions to be available in our classes, which are delegates. So here is a snippet that shows where we can use our delegated properties, when we can apply property delegation. So we can use delegated properties for top-level properties, for class properties, also for local variables, for class members, and for class member functions and top-level functions. So now switching to the property delegates available in the standard library. So let's start with the observable. It's different than reactive observable stream. It just implements the observable design pattern. So it's pretty useful when it comes to listening to the changes of some property, or yes, that's it. So as you can see, to implement the observable design pattern in Kotlin, we just need to invoke the observable function, and it takes two arguments. First one is initial value. In our case, we are setting it to 1, and second one is a function which is invoked on any update made to our property. And this function is invoked with an old value and new value, and allows us to perform any action we would like to. So in our case, we'd like to just print the new value to the console. And we are also having a few lines in which we are updating the temperature property. And as you can see, we are going to have all the values printed in the result of executing this code. Another useful property delegate is called vetoable, and it looks similar to the observable, but it is responsible for restricting updates to our property by performing a check whether we would like to update the property or keep the old value. So here we are creating the temperature property, and we are delegating it to the object returned by the vetoable function, which also takes two parameters, two arguments, the initial temperature and the function, which should return a Boolean value. So in our case, we are comparing old value and new value, and we are checking if the difference between them is big enough, if it's bigger or equal to 10. So we are also testing our property by assigning it to a different values, and as you can see, it works correctly. It updates the property only when the difference is big enough. Observable vetoable. Actually, it doesn't exist in a standard library, but if you'd like to practice writing your custom delegates, you can try to do it at home. And I think it would be pretty useful to have it also in the standard library. And we can try to do it by extending the observable class, for example. And the last one I will describe here, available in the standard library, is lazy. So as you probably know, this will compile to the, this delegate is represented by the code above. So as you can see here, we have a private property underscore user repo, and at the beginning it is initialized to some simple object representing an initialized state, and we also have a public user repo immutable property, and we are just checking upon the first access to this delegate if our underlying property is in the uninitialized state. If it's uninitialized, we are initializing the user repository class and returning it. So now let's switch to Android. And for example, here is a nice example how we can use property delegation to improve the way of handling shared of saving and getting values from shared preferences. So what we would like to do here is to create our custom delegate that will update the value in shared preferences whenever we are updating it. For example, we would like to have a property called score of a type integer, which would be delegated to an external delegate. And whenever it is updated, for example, incremented, we would like to update it also in the shared preferences automatically. So here's how we can achieve it. We can create an extension function for the shared preferences, which would take key and a default value, which can be initialized to a default value. And here, in our getter, we would just invoke get integer function, passing here the key and the default value. Also in the setter, we just perform edit, put int, and apply operation. And why is it better than the standard way of dealing with shared preferences? So for sure, it allows us to reduce boilerplate code, right? But the other thing that I like really much is that we don't need to mess up with the shared preferences keys. So because it's potential point where we can do some when we can mess up with our code. Of course, we can put our shared preferences keys to some constant fields in a companion object, or to the public or to the final static fields in Java. But I think this way is much more cleaner, because we are just instantiating. We are just instantiating the property, and it handles its update on its own. Also, another technique I would like to say about is something that we can call bundle delegate. And this is the stuff I really hate in Android. I mean, saving the state of the view before our activity or fragment gets destroyed or detached. I just hate writing this simple and boring code every time I have to do it. But there is actually a nice way to also clean this stuff up by creating a property delegate. This time, we are going to create an extension property, actually private extension property, for the bundle class. So let's take a look what is going on here. We are creating a bundle delegate seal class, and we are adding a subclass integer, and that extends the bundle delegate seal class. And whenever the getter is invoked, we are just returning the getInt function, and the same similarly with the setter. We are invoking putInteger function on the bundle instance. And again, this is cool because we don't have to declare the bundle key inside our code. It's just the property. We just can invoke the outState argument or saved instance state in onCreate, and update its score property, which we declared as an private extension property, and update it with a desired value. So also we can help to avoid potential memory leaks. So we all struggle from time to time with memory leaks on Android. For example, when it comes to dealing with fragments and detaching the fragments or destroying the activities and recreating them. And also, guys at Google struggle with this, so it's kind of normal stuff. But we can help it by creating a custom delegate that will be also aware of the lifecycle state. For example, lifecycle of our fragment or activity. So let's take a look what is going on here. Basically, we are extending the lazy interface, and we are also implementing generic lifecycle observer by our lifecycle aware class. And we are passing here a lifecycle as an argument to the constructor. And we are also having the property called initializer. So it looks, as far as it comes to the implementation, like a normal lazy, but take a look that we are adding the observer to our lifecycle. And whenever there is a change of the lifecycle state, we are listening to it. And for example, if we want to clean the property, if we want to free the property when the onStop event is, is received, we can assign our underscore value property to an uninitialized value object, or to null if you like nulls. So yeah, this way we can assure that the property will not make a memory leak. So it all looks quite nice, and I really like using it because it helps me enjoy programming in Android again. But we should be aware of the trade-offs that we have to pay for using the property delegation with the built-in support for it in Kotlin. So let's consider this simple example. We have a simple class with one property delegated to some property delegate object. So let's take a look. What is the JVM corresponding implementation of this code? So actually, a pro tip: you can preview the JVM bytecode of your Kotlin class on Android Studio or IntelliJ with the Kotlin plugin by pressing double shift and writing show Kotlin bytecode, and then the window with the bytecode will appear. But if you are not familiar with JVM bytecode, you can press decompile button, and it will show the Java representation for this bytecode. So this way we can decompile our Kotlin to the Java corresponding implementation. So as you can see, there is a couple of there's a couple of issues which our property delegation creates. First of all, notice this static final delegated properties array. It's static, so it decreases our memory performance for sure, because it will be never garbage collected. It's instantiated on the application startup time. So for example, if you have thousands of delegated properties in your code, then and if you have a really big project, it can just slow down the startup time. Another thing is that this delegated properties array, which holds metadata that are needed in getter and setter function, is using reflection. And as you know, it's also not so optimal when it comes to the execution time. And one last thing is the mutable property makes the compiler generate two additional functions. In our case, it's getP and setP. And as you know, on Android, it is not good to have too many functions, especially if you're targeting Android versions lower than Lollipop. So this is all that I have for you today. And let's sum up the presentation and all the stuff that we should take from it. So first of all, we need to be aware that the property in Kotlin is something more complex than a JVM field. And also, another thing is that we can extract the getters and setters of our properties in Kotlin then external delegates, which can be a class, or if, for example, we would like to have only one implementation. For various properties, we can use object as a delegate. We can use observable, vetoable, and lazy, which are available out of the box in the standard library, and they are really cool. And also, it is really useful to use property delegation on Android, but we have to be aware of the trade-offs that we have to pay for using it. So thank you for listening to my presentation. If you would like to take a look at those slides once again, you can find them on slides.com/Samuel-Urbanowicz. Also, if you are interested in learning about design patterns in Kotlin and general applications of the standard library features, you can check out my book. So now it's time for some questions, if you have any. Or some comments. If not, you can discuss it later with some beer or not beer. Okay, thank you.